So, with colonizing other planets, there's a lot of talk about getting people to exo other planets. And there's a lot of excitement. But I think the main focus should be on something different for the meanwhile, and that is getting more people into space stations and into space for several reasons. And I think we should put off the goals to go to other planets for a very, very long time until we get this completed. And this is why. First of all, this obvious thing that it's just closer. Closer has a ton of advantages. First of all, if something goes wrong, it's easier to bring back people. This means we can also have, or if something bad event is going to happen, like a solar flare, easier to bring back people. It's easier to inspect things, to fix things if something goes wrong and everything is closer. You can do many, many more flights back and forth to perfect the technology and everything. Why not? If you fly rocket 20 times, he's going up and down the atmosphere. You have a lot more times to perfect that for other places. Another one is you can develop a lot better infrastructure that's just for in between. It's like refueling modules and stuff like that, and practice a lot more of that, because we're going to need that for the big Mars trip, to have good refueling structures or better communication systems and all this other stuff. Also beyond that, we need to have these, beyond just having the refueling structures and everything, the basic infrastructure in place. We have in-between stuff for people to stop by. The in-between trip to Mars and the moon and everything is going to be a huge deal, and this is going to be the most realistic step for that. So we have that technology being advanced a lot more this way. And the trip is going to be some of the most dangerous, hardest part anyways, with the radiation, weightlessness and everything. But another advantage is that from the commercial and science and humanity aspect is that this gives us a much more immediate benefit there and promotion. You can put stuff close to home, and the development stuff close to home will probably give us more of a commercial outlet with better communication satellites, mining close to home, so it can the product could be for communications a media thing. Other satellites, science close to home which is actually going to be promoted more because weightlessness is more extreme in some ways, so you can do more extreme experiments with weightlessness. You could develop better satellites. We could work on, for both science and commercial, maintaining satellites and fixing satellites more. The weightlessness can also help with commercial development of, people talk about developing new materials such as metallic glass, which so far we can only make well in like outer space, which is super, it reflects mechanical energy super well, so stuff bounces and does all these other cool things. It's basically a glass made out of metal with like no crystal structure, and it's really good at absorbing and redirecting energy, well, mechanical one. So the science aspects, remember for outer space, some of the best solar panel stuff was developed in space, and space really helped with the solar industry. Space has really helped with the ultrasound for medical industry. Space has led us to discover cool stuff about chemistry through weightlessness, so we don't have the gravity impact and other things. We have then we have weather satellites, hugely important, communication satellites, and much more. It would also be more for humanity, in my opinion, because having more people going to space closer home will inspire people with a pale blue dot, both like having images of the world and stuff like that, but also humanity with like just giving free internet and stuff like that. So I think closer Earth would be more helpful for most people. But the biggest challenges I still see in close to home as they're far away in many ways to overcome. Besides the length, and the problem is if the trip is safe, the length doesn't really matter as much. And what makes the trip dangerous is radiation, weightlessness, and loneliness. Now, radiation is much more in outer space, in some parts of outer space that are close to home, than it is on the moon. Depends on where on the moon, and compared to where in local, but it can be. And it's the same as the Mars. Now it's different than living 50 or 60 years from there, but the radiation is more, so the same concern. So we have to overcome it in both places. Why not overcome it closer home for the longer trip? The weightlessness problem is much more of a problem where you're actually weightless compared to on the moon or Mars. But we can return you back in case it gets too much. So, and weightlessness is more than just bone loss, because it also redistributes the fluid, so people's faces actually puff up a ton in space, which puts too much pressure on the eyeballs, puts pressure on the brain. It messes up the digestive system. If you burp, liquid comes out, which can make burps very dangerous. Like throwing up, but you're throwing up in space, and that liquid can flow around and clog up, and it's not like this falls to the ground. It's known to cause dizziness, which can cause a host of health issues and fatigue and stuff like that. So muscle loss, which can, and the fluid redistribution can really have a negative impact on the heart, but that's the most extreme. And we also don't know how much gravity you need to, we also have no idea about how much partial gravity stops stuff. Like the way fluids have been redistributed throughout your body have a lot of negative impacts and dizziness. How much gravity do you need to stop certain aspects of those negative impacts is an unknown one. But complete weightlessness is the most extreme by far we know, and that's something we can look at. Loneliness will be a huge issue for a lot of these trips. And we can start seeing it close to home. I mean, you can also do loneliness to isolate people in pods on Earth, but there's a quick escape in these places. Also in outer space, if something goes wrong, where there's no atmosphere, decompressing and stuff, it's a lot bigger deal. But we also have people close by to help you more. So that's why. Now there is a big thing that there are a couple of big things that you cannot simulate on a space station that would be on another planet, and that has to do with geology and weather. So geology, every planet, a lot of our other planets have a lot of dust. Dust is a huge issue because these dust can have electrostatic properties, meaning they can make like little static charges, which can make them, and other properties makes them really sticky stuff, so they can really clog up stuff. And beyond that, they can damage electronic property stuff because of the electrostatic. They can damage wheels, moving stuff. They also are a lot harder, so they scrape stuff and scratch stuff a lot more. They have breathing in any dust, but especially these electrostatic charged small dust, is carcinogenic and bad for your lungs. So you have that thing you can't really as well do. If you're doing something depending on the atmosphere, like flying a helicopter on Mars, you can't do as well. Then you don't have as much ability to try out new processes with minerals, such as how would you produce a brick on Mars or other construction on Mars or the moon. My solution for that is develop it still on Earth more, because it's a lot easier to simulate that stuff with the geology that I talked about on Earth. Also with a thin atmosphere and stuff, it's a lot easier to simulate a thin atmosphere on Earth and different chemical ones. That's not that hard. The geology a little more, but then I would say send out more basic science missions to the planets that are a lot less risky, but made to collect a lot of science over many places. And that way it may be a little better, because if they can explore many more places than human beings with less risk, they could find the best suitable habitats much faster. And to some extent, if these robots can start producing stuff, then you don't have to worry about the human being producing it. Maybe even have it all produced by robots, maybe not. That's a little more extreme out there, but I don't think it's as much of a loss, but I am putting that out there. Well, thank you very much for... Oh, another challenge that is huge challenge that I forgot to say, and I'm just going to bring up is heating and cooling. A couple other ones, heating and cooling, and food, water, air, and waste. So heating and cooling in outer space is a lot bigger deal. It's going to be a big deal on the moon and Mars, but not as much, because you don't have an atmosphere. You have the direct sun, but you don't have an atmosphere to radiate stuff off. So stuff can heat up really quickly. And then it can also cool down really quick. But it can also be very cold if it's being blocked out by in the shadow or something. But if it heats up really quickly from the sun, it can't cool down very much because the sun is just hitting it. And air really helps cool down stuff. It's even easier on the moon because to some extent you can use the mass of the moon to help cool you down or insulate your structure. And heating and cooling is also a big deal, not only for life support, but also if you want to keep in cryogenic fuels, which are very cold, pressurized fuels, because they need to be, because if fuel heats up, they expand, and that can burst the tank, or you might not be able to carry as much fuel, or it's harder to pump it because it's less dense, it's more of a gas than a liquid, and there might be fuel leaks, stuff like that. Another thing is, it's going to be more of you still have a chance of food, water, and air production in a closed habitat for satellites and stuff. Maybe you can even argue more, because you have to be much more recycling. You can't bring in new chemicals from the outside, from the soil and stuff. Soil chemicals you'd have to filter, but if you can do it reliably with very little input in a space station, it's probably a lot easier to do it on another planet where you can actually input stuff. Now, input stuff you would have to filter out potentially toxic things and everything, but you could try that much better on Earth, just working around with that technology. And I don't think as much chance as the basic things with making a greenhouse. I mean, if you get a fully closed habitat going, which is pretty much impossible, you wouldn't even have to put in anything new. And also disposing of waste. Again, much more of a challenge in the space station, and much more important when you can't throw it out the door. And that waste can then be recycled for better food, water, and air. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. But with your help, I think I can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Thank you again very much. Goodbye.